Hi everyone. Today we will discuss summation of series. Now when we consider the summation of series, so it is not necessary that all series either they are in arithmetic progression, geometric progression or harmonic progression, because for these three particular series we have certain relations, like we can calculate the nth term, we can calculate sum of their terms and so on. But all series may not necessarily be as part of arithmetic progression, geometric progression or harmonic progression. It can be of different type. Now if there are different type of series, then how to calculate the sum of that series? So that we consider under the summation of series. Now the summation of series or the sum of any particular number of terms, that is represented by sigma. So here you can see this notation, this sigma, we just write like this. So this is your sigma notation which represents the sum of the sequence, sum of the series and so on. So this is sigma notation. Now if you have suppose n number of terms and if you want to find the sum of those terms, then we write a1 plus a2 plus a3 plus dot dot an. So either you write this completely in this expanded form, or we can write it in the symbolic form, that is summation of AR. R means the rth term. Summation of this AR, rth term, where R varies from what? 1 to n. This R varies from, these are the symbolic representations, summation of AR, where R varies from 1 to n. So if you consider R, and this summation means the addition. This summation or this sigma notation means the addition of the terms. Here we have the addition of the terms. So in general we have represented each and every term here. The same thing, it can be represented in the symbolic form. And we say summation of AR, where R varies from 1 to n. So if R varies from 1 to n, so if you take the first term R is equal to 1, so that will give you what? A1. If you take R is equal to 2, so that will give you A2. R is equal to 3, this A3, and dot dot R is equal to n, so we get this as AN. Summation, that gives us the addition relation, so we have this plus 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 and so on. So now this you can find, this is same as this one, so symbolically we can represent like this. Now here if you consider this A1 plus A2 dot dot AN up to infinite number of terms, the series can go up to any number of terms. It can contain finite number of terms, it can contain infinite number of terms. So if there is no limit here, then we call it as infinite series. If the number of terms tends to infinity, then that becomes your infinite series. Now let us see how we calculate or how we use this sigma notation or the summation of series method to calculate the sum of the terms of any series or any sequence which is not particular in arithmetic progression, geometric progression or harmonic progression. Here, so before that, let us see some of the properties of this. Now if you have summation of suppose two series, summation of two series, one is represented by AR, another is represented by BR. AR, when R varies from 1 to n, that gives you a series A1 plus A2 plus A3 dot dot AN. BR, when R varies from 1 to n, that gives you B1 plus B2 plus B3 dot dot Bn and so on. So sum of these two series. So when we have to calculate summation of this AR plus BR simultaneously, so we can calculate summation of the first series as well as summation of the second series independently and then just add them, so we will get the total sum. So summation of this AR plus BR means summation of sum of these two series. So that can be equated as summation of the first series plus summation of the second series. So summation of AR where R varies from 1 to n, summation of BR from where R varies from 1 to n. So independently let us calculate sum of this series, sum of this series, add them, we will get the summation of AR plus this BR. Similarly, we can consider in case of this subtraction. So summation of difference of two series. So AR minus this BR. So again we will calculate this independently, we will calculate this independently, and we will again subtract them. So summation of this AR where R varies from 1 to n, similarly summation of BR where R varies from 1 to n. So independently we can calculate this sum, we can calculate this sum, difference of these two, it will be equal to summation of AR minus BR where R varies from 1 to n. Next is, suppose some series, if it is multiplied by some constant k, here you can see some constant k, find the sum and multiply it by k. So it means we can take this k out of the summation. So k summation of this AR, and in the entire sum it will get multiplied by this k. So summation of this AR, again that is same as R varies from 1 to n. So if you have summation of some constant k times the sequence, the sum will be equal to k times sum of that series. So k times sum of this series. Now sum of constant, like suppose 1 plus 1 plus 1 plus 1 n number of times, because this varies from R is equal to 1 to n. So when we say summation of some constant k where R varies from 1 to n, so here you don't have AR, BR where R varies from 1 to n. So don't get confused. This means summation of k where R varies from 1 to n, that means k plus k plus k plus k how many times? N time, because it is constant. So first term is k, when we take R is equal to 1 means first term is k, R is equal to 2 means first term is, second term is k, R is equal to 3 third term is k. So it means similarly we have n number of terms and value of each term it is equal to k, such that the sum it will be equal to n into k. K plus k added n times, so it is just nk. So that way we can use these properties when we simplify sum of, or we calculate sum of the series which are not in any particular order. It can be have a particular order. When I say, it means it is arithmetic, geometric or harmonic. If they are not particular in this sequence, then we can use these methods to calculate the sum of those series. Now sum of n natural number. So if you have, suppose there is a series, suppose you have to find the sum of 1 plus 2 plus 3 plus 4 plus 5 and so on. Okay, this is natural number 1, 2, 3, 4, 5, 6. If you want to calculate sum of such term, so summation of such term where terms goes up to n, 1 plus 2 plus 3 plus 4 plus 5 up to this n. Then, so it means it is sum of first n natural number, sum of first n natural number. So that is equal to, that we call it as summation of this R, where R varies from 1 to n. So that you can see summation. Rth term here it is represented as R. So summation of this R where R varies. So R is equal to 1, so we take this one. R is equal to 2, it means it becomes 2. R is equal to 3, it is 3. Up to n, so you have this n. So 1 plus 2 plus, this is sum of first n natural number. When we say first n natural number, it means the sequence or the series is to start from this 1. It is up to n, so it is up to this n. So sum of n, first n natural number, that is equal to, if you calculate the sum of this, that will be equal to n plus 1 by 2. So if you want to find the sum of first 10 numbers, like 1 plus 2 plus 3 plus 4 up to suppose 10, you want to find the sum of 10. So n plus 1 by 2. So n is how much? 10. 10 plus 1 means 11. Divided by 2, it becomes 55. This is cancelled, so you will get this as 55. Similarly, sum of 20 terms, first 20 terms. So we can calculate 20 into 21 upon 2, so that becomes how much? 10 into 21, so it will be 210. So that way you can always calculate it. So this is the general relation to calculate sum of first n natural number. Now if the sequence starts from this, suppose 3, 4, 5 up to 10, then directly you can't use this relation. You have to calculate it from this one, and then again calculate the sum of these two and subtract in that. So you will get the sum of the remaining term. Directly, if it is starting from 3, then directly we can't start. It has to start from the first number, and that is 1. So if you want to simplify it from here, 3 plus 4 plus 5 up to n, then in that case what we will do? First we will calculate the total sum using this relation. Then we will calculate sum of these two terms. Here there are two terms only, so sum of these terms which is AD. It may be suppose n number of terms this side also. So sum of those terms which are not included in this entire sequence, subtract, you will get the sum of the remaining terms. So that way we can understand or analyze these things. Similarly, suppose this is sum of square of n terms, summation of r square, again where r varies from 1 to n. So sum of square of first natural, again it is first natural number starting from 1. So it means it is 1 square plus 2 square plus 3 square plus 4 square, 5 square and so on up to n square. So sum of squares of first n natural number. So if we calculate, it is coming as n plus 1 into 2n plus 1 divided by 6. Summation of r square means square of first n natural number. R varies from 1 to n. So we get the relation n plus 1 2n plus 1 divided by 6. Summation of cube of n natural number, like 1 cube plus 2 cube plus 3 cube plus 4 cube up to this n cube. So sum of cube of first n natural number. So 1 cube, 2 cube, 3 cube, 4 cube up to this n cube. So that we call it sum of cube of first n natural number. So that becomes your n plus 1 by 2 whole square. This is n plus 1 by 2 whole square. This is square of this one. n plus 1 by 2. So it is square of the first relation. So n plus 1 by 2 this whole square. So that you can also write n square n plus 1 whole square upon 4. Again, if you want to write it symbolically, we can say this is what? Square of, this is what? Square of sum of n natural number that you can find here. So sorry, that you can find here. So summation of this r, where r varies from 1 to n, this whole square. So squaring of that, you get summation of cube of first n natural number. So these three relations if you keep in mind, it becomes easy to simplify problems based on summation of series, whether that series can be of any nature other than arithmetic, geometric or harmonic progression. So it is better to keep this, and they are just simple. Summation of first n natural number n plus 1 by 2, summation of square of first n natural number n plus 1 2n plus 1 divided by 6, summation of cube of first n natural number, that is nothing but the square of the first, that is n plus 1 by 2 whole square, or it is summation of this r varies from 1 to n whole square of that. Now see, we can have the combination of the series. We can have arithmetic series, we can have geometric series, and we can have the product of that. That is termed as arithmetico-geometric series. The product of that. Here you can see, if you consider a sequence in arithmetic progression, so suppose 1, 3, 5, 7 and so on. And in geometric progression, you can consider, suppose this x square, x cube and so on, and here obviously it is 1. So here the common ratio is, first term is 1, common ratio is suppose x, so 1 into x, that is x, x into x, it is x square into x, that gives you x cube and so on. So it is 1, 3, 5, 7. They are in arithmetic progression. This is in geometric progression. Corresponding terms are multiplied. First it will be multiplied by first, second it will be multiplied by second, third with third, fourth with fourth and so on. So that gives you a different series. So it is 1 into 1, that is 1, 3 into x, 3x, 5 into x square, 5x square, 7 into x cube, 7x cube. So with the combination of these two arithmetic and geometric series, we got a new series, that is 1 plus 3x plus 5x square plus 7x cube and so on. That is termed as arithmetico-geometric series. Now if we have this, then how to calculate the sum of this kind of series? Now if you generalize this one, so first term if it is suppose a, second term it will be what? A plus d, where d is the common difference of the arithmetic progression, a plus 2d, and similarly a plus n minus 1 into this d. This is your nth term of that arithmetic progression. Here if you consider this, first term if it is again suppose this a, second term it will be ar, where r is the common ratio, ar square, ar cube up to this ar to the power n minus 1. Now just see this. Now here we have generalized. We want sum of these two. Okay. The first term here we have taken what? A plus d, a plus 2d. We are just generalizing this particular example. So a plus d. A plus d is your second term here. First term was 1, second term was 3 of the arithmetic. Second term of the geometric was how much? X. So this and this it is multiplied. So a plus d into r, because x here it was the common ratio, so it is r in general. A plus 2d is the third term, and here third term is how much? X square, means r square. So it means in general form, this is nothing but the generalization of this. We have considered a particular example here, and this statement is nothing but the generalization of this arithmetic a plus d, a plus 2d up to a plus n minus 1 into this d. Geometric 1 r square, next r cube, and just multiply them. So this is arithmetico-geometric series in general. We have to find the sum of these terms. So multiply that Sn, yani sum of that term, by common ratio r. These are some of the standard steps that we use to simplify such type of question. They are just standard. If you don't follow, you can simplify it, but the calculation will be very lengthy and you will surrender. So it is better to use some of the standard assumption or some of the standard steps. So multiply that sum of that arithmetico-geometric series by the common ratio this r. So r into Sn. That will be equal to ar plus a plus d r square. A plus means each and every term it will be multiplied by r. Then subtract this equation. If it is suppose second equation and previously it was suppose your first equation. See, this was our first equation, this, which is assumed as Sn. Now we are multiplying this by r. So we are multiplying this by r. Okay. Now when we multiply by this r, so you got this r Sn. Okay. Let us treat this as the second equation. Okay. Now first equation minus second equation, you can see Sn minus r Sn. So if you take this Sn common, it becomes 1 minus r. So subtracting. So we are getting this one. Each and every term it will be subtracted with the corresponding term. Now if you observe after this statement, so this bracketed terms, this one, in excluding the first term and the last term here, the remaining terms here which has been kept under this bracket, they are in geometric progression. dr square, dr to the power n minus 1. So they are in geometric progression. So again, using the concept of geometric progression, we can simplify this. So from here we are getting Sn 1 minus r is equal to a, this a here, plus simplification of this. Okay, this is addition of how many terms? N minus 1 terms which are in geometric progression. N minus 1, first, second, third, up to n minus 1, so it is n minus 1 term. Okay, so now you have the geometric series. There are n number of 1 terms. Common difference is also known. First term is known. So directly we can use the formula to find the sum of n terms in GP, and using that we are getting this relation minus this relation, this term. So you have this. So finally Sn 1 minus r, we got this one. So Sn is equal to how much? This entire expression divided by 1 minus r. So just divide, arrange the term, and you will get this Sn. So this is just in the symbolic form. So you are observing complicated statements here. This statement, this statement. Once you solve some particular problem just based on arithmetico-geometric series, only one step you have to do. Multiply that equation by r, subtract both of them, you will get this common. Here you are observing this in a general form, there you will observe in a particular form, and you can make out that this particular part, it is in geometric progression. Once you find that those particular number of terms are geometric progression, use the concept of geometric progression, simplify it, divide it by 1 minus r, and you will be able to get the sum of n number of terms. So these are the standard ways, standard steps. If you follow this, your calculation part, it will be easy and you can simplify it. So now we have that statement. From here, if you assume that common ratio is less than 1, that is mod of r less than 1 means r lies between -1 to +1, and within that limit, if r lies between -1 to +1 and n tends to infinity in the previous example, then obviously r to the power n when n tends to infinity will be what? 0. Because if any quantity which is less than 1 and if it is raised to power infinity, that tends to 0. So from there we get this concept. Using this relation, the sum of infinite terms you will be able to calculate, and this is equal to this. Here you can consider this one. You can see this. R is less than 1 and number of terms n tends to infinity. So when n tends to infinity and r is less than 1, so this tends to 0. So this part will be over. Here again this part will be over. Simplifying, you will get this relation. Okay, so this is sum of infinite number of terms of the arithmetico-geometric series. There is another method. So we have discussed summation of series method. Using the concept of summation of series, we can calculate sum of any different type of sequence or series which are not particular in AP, GP or HP. Similarly, we have observed arithmetico-geometric series. Now there can be some other series which cannot be solved even using the concept of arithmetico-geometrics, because all series may not be necessarily the combination of arithmetic and geometric progression. All series may not necessarily follow the summation of series method. So we have some different method, and we can try those method also in those series which are where those methods are not applicable. So that is termed as method of difference in the summation of series. Now suppose we have a series or a sequence whose sum is Sn such that Sn is equal to u1 plus u2 dot un. Okay, we have u1 plus u2 plus un, its sum is assumed as Sn. If it is possible to express the nth term, yani un, this is the series, just try to understand, this is the series, its nth term is un. Now if you can express that, if it is possible, because this method cannot be used everywhere, if it is possible that un, it can be represented as difference of two terms, like vn minus 1. Any nth term of something, a minus n minus 1th term of that. Okay, so Vn, and that is represented by Vn. So Vn minus 1. Yani nth term of a sequence, if it can be represented as difference of two terms, so it is Vn minus 1. Then sum of this series, that is Sn, it will be equal to your Vn minus V0. Means the nth term of that sequence minus the first 0th term of that, or the first term, the counting starts from first 0th. So Vn minus this V0. Now how it happens, that you can see. U1 from here, U1 is equal to how much? V1 minus V0. U1, if you take this U1, that will be equal to how much? V1 minus V0, first term minus the 0th term, if the counting starts from this 0. If counting starts from first, then it will be the second term minus the first term. So let us say the counting starts from the 0th term, so U1 will be V1 minus this V0. U2 will be equal to how much? V2 minus this V1. U3 is equal to V3 minus this V2. Now add the term. So if you add it, you will get this V1 V1 cancel, V2 V2, yani all diametrically opposite terms that will get cancelled. So that from here, after adding u1 plus u2 plus u3 dot dot un, that will give you what? This un. That is equal to how much? Vn minus 1. So from here, we are getting this un is equal to Vn minus 1. It's clear. So this was our assumption, and we have just broken into different part or each part. Again, if we calculate it back, we are getting the similar derivation, un is equal to Vn minus 1. So here, if we consider this, so summing all that, so u1 plus u2 dot dot un, that is coming as how much? Vn minus v dot. So this way we can calculate. Means idea here is, if you have a series and if you can arrange them as difference of two terms, then from there we can calculate the sum of the terms. So we will have examples on this, and that it will be more clear. It means, just to analyze, just to summarize, there is a series and it can be arranged, the terms of that or the nth term of that, it can be arranged as different of two terms. Then just using this concept, we can calculate the sum of that series. Okay, so we have finished, or we have completed all the conceptual discussion as far as sequence and series is concerned. Now we will start solving problems based on the general concept, based on sum of the terms, based on summation of series, difference method and all that. Thank you.